This is Algebra Lesson 1-4, Properties of Real Numbers. Equivalent expressions. Equivalent expressions are two or more expressions that have the same value for all values of the variable. Examples being, if I had 2 plus 2 equals 4, that's an equivalent expression because 2 plus 2 equals 4, and like 3 squared equals 9. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. Deductive reasoning is oftentimes the reasoning that lawyers will use in the courtroom to be able to prove something is true or false. And a counterexample is an example that shows that a statement is false. So any counterexample would work. If I said all dogs are black and I found a white dog would be a counterexample proving that not all dogs are black. There are many properties in mathematics. These properties are used like rules of a game, and this is how in math you know that something is true, not because someone tells you it is true, but because you can show it is true by using the properties. So the properties of mathematics that we're going to go over are basically properties of real numbers, and these properties will also apply to other things later on in mathematics, which is probably why it's important that you understand these basic properties. One of the first properties is the commutative property. The commutative property says that order of addition or multiplication, well, there's the commutative property of addition, which says the order of addition doesn't matter. 3 plus 7 is the same as 7 plus 3. Then there's the commutative property of multiplication, which means the order in which you multiply things does not matter. I can multiply 2 times 3 times 7, or I can multiply 7 times 2 times 3, and I will still get the same answer both times. The easiest way to remember the commutative property is thinking of a commute to get from place A to place B. For example, if I was going to commute to work, I could drive down through Tacoma, all the way across the Tacoma Narrows Bridge, go over to Seattle, take the Seattle ferry back to Bremerton, and then get to work. It would take me a long time, but I could get there. Or I could drive straight to work. How I get there doesn't matter as long as I'm to work on time. The associative property has two parts to it, the associative property of addition and the associative property of multiplication. The associative property of addition says how you group addition does not matter. What numbers you put in parentheses doesn't matter. For example, if I have 2 plus 3 in parentheses plus 4, that's still going to equal 9, whether or not I have 3 plus 4 in parentheses, which would be 7, plus 2 also equals 9. There's also the associative property of multiplication. How you group multiplication doesn't matter. I can do 2 times 3 first and then multiply that by 4. So 2 times 3 is 6. 6 times 4 is 24. Or I can multiply 3 times 4 first, which is 12, multiply that by 2, and I still get 24. We also have the identity property of addition. This says that adding 0 to a number doesn't change the number. A plus 0 equals A, 9 plus 0 equals 9. Adding 0 to something does not change it. That's the identity property of addition. So the identity property of multiplication goes along the same lines. What can you multiply a number by and not change that number? Well, that would be the number 1. Multiplying by 1 does not change your number. So A times 1 is A, 9 times 1 is 9. The zero property of multiplication says for every number n times 0 equals 0. So in other words, whenever you multiply something by 0, you get 0 as an answer. Whether that number is positive or negative, you still get 0 as an answer. Then there's the multiplicative property of negative 1, saying that we multiply negative 1 by anything, it just changes its sign. So if I have negative 1 times 56, that becomes negative 56. If I have negative 56 times, if I had negative 56 times negative 1, I would get positive 56. So you have to learn to identify the properties. The easiest way to do it is to see, because the two properties that are most likely confused are the associative property and the commutative property. So to tell you the difference between them, see if they have parentheses. If they have parentheses, see if different numbers are in the parentheses. If there's no parentheses, see if you have numbers that are the same on both sides of the equal sign, but just in a different order. Everything else you just look at and see if you can identify the property. Here we go. On number 1, it says 31 times 0 equals 0. Well, that reminds me of a property we just discussed as the zero property of multiplication, because anything times 0 is 0. So this would become the zero property of multiplication. Number 2, we have x plus 3 in parentheses plus 6 equals x plus parentheses 3 plus 6. If you notice, we have an x, a 3, and a 6 in the same order on both sides of the equation. However, the parentheses moved. They were originally around the x plus 3, and then they moved to the 3 plus 6. So this would be the associative property, because how we grouped things, who you associate with, your group of friends changed. In this case, it changed from the group being x plus 3 to the group being 3 plus 6. So this would be the associative property of addition. All right, last but not least, number 3 says 5 times x plus 0 equals 5x. So here you noticed all we did was we added a 0 and we got the same answer as if we didn't have a 0, which makes that the identity property of addition. And you can use your properties to help you solve some math problems using mental math. For example, a movie ticket costs $6.75, a drink costs $1.90, popcorn costs $2.25. What is the total cost? Use mental math. Well, I'm going to have to actually show you what mentally I would be thinking of, but my brain is looking at this going, ooh, $6.75 and $2.25. The 25 cents from here and the 75 cents from here I could group up. So my brain says take 6.75, group it with the 2.25 together first, and then add the $1.90. Because if I think about it, 675 and 225, this becomes one whole number. So that becomes 1. 6 and 2 is 8, plus 1 is 9. So I have 9 plus $1.90, which gives me $10.90, which I could have done all in my head, but I had to show you what my brain was thinking. But that's how you can use some of your properties to make things a little bit easier. All right, writing equivalent expressions. When we write equivalent expressions, we are trying to write things that are going to be the same on both sides of the equal sign. Some people call this simplifying. Right? Simplifying doesn't necessarily mean you're solving something. It just means you're reducing it to the easiest terms possible. So if I have 4 times 8n, that basically is like taking 4 times 8 and multiplying that by n. 4 times 8 is 32, so we have 32n. 3 plus 5b plus 7, well, I could change this to be 3 plus 7 because those are like terms, plus 5b because there's no other term here in this that has any b's to it. 3 plus 7 would be put together, grouped together, associated together, and that would become 10 plus 5b. I should probably circle my final answers here, so a little box. Number 3, I have 8xy divided by 2x. Well, that's like saying 8x times y. Well, that's a terrible looking y, isn't it? Let's try that again. That's better. Divided by 2x. Well, that's the same thing as saying 8 over 2 times x over x times y over 1. Well, 8 divided by 2 is 4, x divided by x is 1, and y divided by 1 is y. So I have a 4 times 1 times y, which is just 4y. Some of you will be able to do that in your head, while others of you will need to write it out like I showed to understand it. But as you get more and more of these, and you do more and more of these, you'll get more familiar with them, and you'll be able to do them in your head quite quickly. Now we're going to look at using deductive reasoning and counterexamples. It says, Is the statement true or false? And if it is false, give a counterexample. It says for all real numbers a and b, a minus b equals b minus a. So no matter what, if I take a and I subtract b, I should get the same answer as if I take b and subtract a. I'm looking at that thinking, well, that's definitely false because I just think of the numbers of 3 and 2. If I let a equal 3 and b equal 2, then I have 3 minus 2 is supposed to equal 2 minus 3. Well, 3 minus 2 is 1, but that does not equal 2 minus 3, which is negative 1. So there's my counterexample. I can just give you an example, and I could use any two numbers I want that would show that it is a counterexample. I could use 10 and 6. As long as you can find one counterexample, you have proven something to be false. Number 2 here says, for all real numbers a, b, and c, a times b times c equals a times c times b. Now I'm thinking about this, does it matter if it's positive or negative? Probably not. So if I let a equal 1, b equal 2, and c equal 3, will these stay true? So I have 1 times 2 times 3. Is that going to equal 1 times 3 times 2? Well, this is 1 times 2 is 2, 2 times 3 is 6, 1 times 3 is 3, 3 times 2 is 6. This is true. So I'm going to say that this is going to be true because I cannot think off the top of my head of a counterexample which is going to make that false. All right. The question to answer at the end of your notes today. Answer the following at the end of your notes. Is it possible to prove that a statement such as a plus b equals b plus a is true by showing that there are no counterexamples for the statement? In other words, they're trying to say, can you prove that a plus b is equal to b plus a by showing no counterexamples? Please answer that in a complete sentence at the end of your notes.